Hi everyone, welcome again. In this video, we are going to see how to handle exceptions and how to report those exceptions in the API. So let's get started. In the last video, we had a quick look at how to use response entity, and we saw we can actually use status method to return a custom status. So in this case, for example, we are returning the bad request status back to the client. And in the same way, we can handle the exceptions and the error. So if something goes wrong, we can capture that exception and then accordingly, we can return a status back to the client. In this example, as we are returning the bad request status and the API is up and running, if we retry the same request, send, then we see the status 400, which is bad request, which is kind of working fine because we are returning error back to the client. But if you notice, there is literally no information in the response. So client doesn't know how to react if a request failed. Should it retry? Should it retry after some time, or what to do? So client is unaware because there is no information. Client doesn't know how to react to this error. And we will see later how to return some information back to the client in case of an error or exception. Another option, which is actually not a good practice, is not to handle the exception at all. Let it bubble up and it will be reported back to the client. Let's see an example of that. So let's say instead of returning the response, we can comment it. Let's say we have a method which is responsible for creating the user. So we can say some method like this. And this method is responsible. It has some business logic to create the user, but for this demo, we are going to mimic what if this method throws an exception. So for some reason, let's say there is an exception in this method and we are not catching this exception. Like this. So what would happen when a client makes a request, a post request to create the user? We will call this method from the controller, and this method will throw the null pointer exception. And notice that we are not catching this exception. We are not providing any information, specific information back to the client. So in this case, it will return the uncaught exception back to the client. Let's rerun the API and retry the same request. The service is up. Let's hit this. So if you notice, this time we have some more information. We see the status is 500, internal server error because we returned an exception, and the by default Spring Boot shows timestamp, status, error, the description of error, and the path, which means which endpoint the client called when this error occurred. So at least we have some more information in this case, but not handling any exception, not catching any exception is not a good practice. We will see a better way to handle the exceptions in the REST API. A better solution would be to have a centralized exception handler that can handle all the uncaught exceptions in the API codebase. So no matter which controller was called, if there is an exception, that exception will be caught by that exception handler, and it will always return a consistent error response back to the client. So let's write that exception handler. To do that, we'll create a new class in the package exception, and let's create a new class. We'll say custom exception handler. And we will then extend response entity exception handler. All right. And we need to annotate this class with controller advice. Now we can write methods in this class to handle specific exceptions in a centralized manner. So for example, if we create a method here, response entity, that would return a response entity, and we can name it, let's say handle NPE, handle null pointer exception. Then the next thing is to tag it with @exception handler. And @exception handler accepts an array, which means we can pass multiple exceptions to this handler. That means all the exceptions that we provide to this annotation will be captured by this particular method, like this. And as I said, this is an array, so we can pass multiple exceptions here, but because we are simply handling null pointer in this demo, so we will provide only null pointer exception here. Now we will inject two arguments. The first one would be runtime exception because we are handling runtime exception, and the second one is web request. And then we need to call one of the methods defined in this exception handler to handle the exception. So we will say this dot, and you can see there are so many handle methods available in the parent class specific to different errors. So for example, this is async request timeout exception. This is to handle the error response exception. This is to handle the HTTP message not writable exception. You get the ideas. And depending on the use case, we can call one of these methods. And in this case, we are going to call one related to internal. Yes, this one. Handle exception internal. Now the first argument that this method accepts is the exception, which is of type exception. And because in this method, we are capturing the runtime exception, so we can simply pass exception as it is. All right. The second argument is the body, the payload that we want to pass. Right now we can leave it null, but we will soon pass a body. The third argument to this method is headers. If we want to enrich some headers while returning the error response back to the client, we can do so. But in this case, we will simply pass the empty headers. So we will say new HTTP headers. The fourth argument is the HTTP status code. So we'll say HTTP status dot, in this case, internal server error. And the last argument is web request. All right. So what we did, we created an exception handler class, which is extending response entity exception handler, which is coming from the Spring framework. Then we annotated the class @controller advice annotation. We created a new method in this class. Then we used this exception handler annotation on this method. And we are saying that we want to capture null pointer exception. All right. From the body of this method, we are calling this internal method from the exception handler, and then we are passing these details to this method. The missing thing is we are not passing a payload. The simplest possible payload is that we can pass an error string. So for example, we can say something went wrong, like this. And if we rerun the API to test this exception handler, the service is up now. Let's test the request. If we rerun this request, this time we get the message something went wrong. So what happened when this controller was called? It executed some method, and here, because we are not catching the exception, so this will be caught by the custom handler that we wrote. And in this custom handler, because we have a method that can handle the null pointer exception, so this method was invoked. And with the help of this method, because we are passing this body, which is the payload error response, and that's the same response that we see here on the console, something went wrong. All right. Now, how can we better improve the error response? Instead of just returning a simple string, we can actually have a proper error response. So in the response package, we can create a class error response, and this error response class can have certain fields. For example, message, timestamp when this exception occurred, and then we can have getters and setters, a public constructor, and then in the custom exception handler, instead of passing this string, we can actually return the error response, like this. So we can say exception.getMessage, and the second argument is the timestamp, so we can simply pass the current timestamp like this. There is one benefit of having a custom error response, because we need to be careful what kind of information are we returning back to the client in the error message. We don't want to expose the internal details. We don't want to expose the sensitive data in the error message like stack trace or method names or the class names. So we can create a custom error response. In that way, we have the control over the information, over the error response that we are returning back to the client. So in this example, we are only exposing two fields. The one is the exception message and second is the timestamp. Similarly, we can have few more details depending on the project and the use case. And this time, if we retry the same thing again, if we rerun the API and retry the same request, we see the error response on the console. So we see the status, which is 500, because that's what we are setting in the method. And then we see the message, a useful information, a useful message that client can understand, and the timestamp when this exception occurred. So in this video, we learned how to use controller advice and exception handler annotations to create a custom exception handler, a centralized exception handler that can catch any uncaught exception occurred in the API codebase, and how to create and pass on an error response back to the client. So that's it for now. See you in the next video. Thanks for watching.